In the previous tutorial, we have discussed what is similarity and dissimilarity between the objects and why it is necessary to calculate the similarity and dissimilarity. The reason is because we want to use similarity and dissimilarity to form clusters within a data. In this tutorial, we will see what are the measures of similarities and dissimilarities like Euclidean distance or Minkowski distance. We will study the properties of them, and finally we are going to see the formulas that will help us calculate similarities and dissimilarities. The first term that I'm going to define is the proximity measure, which is a very important term. Now, proximity measure is basically a function. It is basically a function that tells, or which it is a function of the proximity between two objects within a data, and we describe this to measure the similarity and dissimilarity basically. So this is a function of proximity between two objects to determine similarity and dissimilarity. All right. So various proximity measures that we will study, they are Euclidean distance, and it also includes a variation which is the Minkowski distance. And then one important thing is that these two distances are useful when we have dense data, right? For example, if we have the temperature such as time series or 2D points, right? For 2D points, this type of distances are helpful to find the similarity and dissimilarity. And then comes the Jaccard or cosine distance. And basically these two distances are for discrete data. These are for discrete data. So these are the proximity measures. So now the question is how to calculate these proximity measures. And basically discrete data, or we can also say it as sparse data. Not discrete, it should be sparse data. So example is like some documents. So these are the proximity measures that we have, and now what we are going to do is we are going to start with the first one, which is the Euclidean distance. We'll start with the Euclidean distance. So Euclidean distance d is the distance between two data points x and y, which is defined as under root of sum. This is a symbol of summation, which goes from k equals to 1 till n, and here I will write xk minus yk raised to the power whole square. So in this formula, n is the number of dimensions. N is the number of dimensions that we have. For example, 2D or 3D or even higher, right? So n represents the number of dimensions and k represents the number of kth attributes or components, or we can simply say components. So we use this Euclidean distance to find the distance between two data points, and we will study the properties of Euclidean distance to figure out how there are some very interesting properties of Euclidean distance. We will see them, and basically this formula is very useful and you should remember this formula because we are going to use this formula in k-means clustering algorithm. So another variation of the same formula is basically a generalized form of this formula, which is given by Minkowski, and it is known as the Minkowski distance. And the formula which was given is that if you want to calculate the distance of x comma y, you can actually write under root of summation goes from k equals to 1 till n, and here we will write xk minus yk, and then raised to the power r, and basically xk minus yk comes under modulus sign, and finally this whole thing is having an exponentiation of 1 upon r, this whole thing. So this is the distance which was given by Minkowski. If you will put different values of r in here, you will be able to find out that you will get the Euclidean distance. So let's put the value of r equals to 1. We will first put the value of r equals to 1. If you will put r equals to 1, it is most commonly known as L1 norm, because the value of r is 1, so we call it as L1 norm. If we have r equals to 2, we call it as generally as L2 norm, and if r is infinitive, we call it as L infinitive or L max norm. So just some fancy names for different values of r. Alright, so what will happen if we have r equals to 1? So when r is equals to 1, we have some common examples, which one very common example is the Hamming distance, and this means that if the value of r is equals to 1, we say it is Hamming distance, because this formula will be able to calculate the Hamming distance, and basically Hamming distance is used to calculate the number of bits that are different, right? So if the number of that are different to objects, so if we have r equals to 1, then we call it as a Hamming distance. If r equals to 2, we call it as a Euclidean distance. So you can see that this single formula will give us different types of distances, this Minkowski distance. If you put the value of r equals to 2 here, you will get the Euclidean distance formula. Alright, so the next one is the r infinitive, and this is known as supremum distance. Supremum distance. Alright, so now we have a measure. Most importantly, we are going to use Euclidean distance in clustering algorithms. So now we have a formula which we can use to calculate the distance between 2 points, and then we can use it to judge whether the 2 points are similar or dissimilar. Now let us study some of the properties of Euclidean distance. Alright, so let's discuss the first property of Euclidean distance, which is known as positivity. And this property basically says that the distance d from a point x to a point x, which is basically the same point, if this distance is greater than or equal to 0 for all values of x and y, so this is the positivity property, which says that Euclidean distance between two same points are always greater than equal to 0. Now the second property is the symmetry. The symmetry property says that the distance from a point x to a point y is always equal to a point dy comma x for all values of x and y. So now we have some two properties, and we have the last property, which is the triangle inequality. And the triangle inequality says that if we have a distance from a point x to a point z, it is always less than equal to point to the distance of x comma y plus the distance of x y comma z for all points x, y, and z. So these are the basic three properties of Euclidean distance. Now, why we have studied these three properties is because if the Euclidean distance specifies all of these properties, then we call these measures as metrics, right? So if the Euclidean distance that we have found has all these satisfy all of these properties, we call them as metrics. Next thing is that if only third property holds true, right? So I'm just going to write that if triangle inequality is the property that is satisfied or it is true, then it can be used to increase efficiency of clustering algorithms. Efficiency of clustering algorithms. So that's why these properties are necessary, because now we can actually tell what are the metrics, and we can also use this third property to increase the efficiency of clustering algorithms. So that's all for this tutorial. In the next tutorial, we will study different types of clustering algorithms. So that's all for this tutorial. Thanks for watching.